Hello and welcome to our next lesson, 1.2 on statistical questions and getting ready for an activity. So we want to understand the characteristics of statistical questions. We can ask questions to better understand our world, and when we try to understand things in a mathematical way, we talk about statistics. So some statistical criteria, or the criteria we would use for understanding things mathematically or statistically, we want some variability in what is being looked at. So if I were to ask, what is the year that America became a country, there's no variability there. You could ask, what year do you think uh, the country was started? And then you could do some variability on that. But we want variability of kinds. Typical ones are things like height or shoe size, maybe favorite color, that kind of thing. And it can be measured using data. So we'd want to be able to classify it. Characteristics of a good hypothesis. Now, there are many kinds of questions, and then there are statistical questions, and that's what we're working on. We do this to better understand some things, and sometimes we have an idea of what connections might be existing in a situation. We might say, for instance, the amount of time spent using social media affects a student's grade point average. And that would be a hypothesis that we think is true, and we'd use statistical measures to figure out if that is a good assumption or educated guess. Hypothesis, a good definition is educated guess. So uses language that is clear, specific, and measurable. We wouldn't want to just say, does social media affect GPA? We might want to say, to what extent does it? How much time spent in social media produces what result in a GPA? So we want to know, the GPA is pretty measurable, the amount of time spent be measurable, being specific so that we don't have what we call kind of some hidden variables or lurking variables that can affect an outcome, but we never really are looking for them. We want to be specific. This thing is what we're looking at in this result, and it should be clear. Okay, so here's some examples. A good hypothesis versus bad. Good ones are clear and specific, testable with math or data. Is it reproducible? Did it just happen one time and then can't be really useful for future interpretation? Based on logic or prior knowledge. We should have some understanding of what is being looked at and the things that are affecting what we're looking at. Sometimes it's nice just to have no idea, and we just that's how we start learning about things. I don't know how DNA was figured out, but there must have been some sense that there was something there to find, but we didn't have, I can't imagine that we had the understanding that we now have, obviously, before we researched it. So it's good to have some prior knowledge, but it's also good to be prepared to find information when we don't really have a good sense of what's happening in a situation. All right, focused on one idea. You don't want to have things that can be affected or can lead us down rabbit holes. We want to focus on one thing, look at one situation, and understand it before we start expanding what other things might be involved in a system. These are going to basically be the opposite of these things. If it's vague, if it's not testable or able to express mathematically, it contains opinions or bias. Some people might argue you can't avoid opinions or bias. We can only try to understand how that can be kind of eliminated or taken out, but it might just be part of the process, and we have to use our understanding of that. But we don't want to have too much that is attributable to the views of the person looking into the information. We want objectivity is a good word there, and we don't want things that are not logical. Okay. What's a good and bad? What are good and bad items with these hypotheses, and this is our last slide. So these are a bunch of hypotheses. You could argue, are they good or not, and to what extent? So I'm going to say whether or not one is good or bad, but I'll also point out what might be something that could be an issue or could improve. If a plant gets more sunlight, then it'll grow taller. I would say that is a good hypothesis. We could improve it by saying, how much sunlight are we giving? You know, and does the temperature in the room affect? You can have sunlight, but it can be, 10 below zero. So there's more that we could do here, but this is a generally good one. We're trying to find out how does sunlight affect the growth of a plant, let's say. Plants are cool, not so good. And this one is, I guess I'll use B for bad. That's a pretty subjective thing. I like making airplanes, more of a declarative statement. I was going to go back up here. If I wanted to make this into a better one, I could say, what is your favorite plant? And I could give like 5 options. There's ways that you want to be specific. You've said, what's your favorite plant? And you just had people fill in the blank. That could be pretty broad. You might want to focus. You could say indoor plants, outdoor plants, perennial, annuals. You could try to make this into a better survey kind of question, but right now it's just a statement. If I fold the wings evenly, then the airplane will fly farther. I think this is a good hypothesis. I think we need to talk a little bit about what does it mean to have even wings. I think we have an idea about that on a paper plane, but what kind of airplane? You don't fold wings on a plane down at the airport, so this is obviously a paper plane. And then how far does it fly? There's other variables when you're doing the experiment you might want to consider. But anyway, generally a good hypothesis. It's asking about an effect, and we're trying to understand how this one thing could affect it. Students who practice multiplication daily will solve problems faster. Okay, another good hypothesis. It'd be nice if we said how much practice. How is that practice developed? Like, is it progressively harder problems, or is it a bunch of the same kind of problems? And then what does it mean to be faster? Also, this says you're solving it faster. We'd also hope, and maybe it's assumed, solving a problem means your answer is correct. You can solve problems and have them be incorrect, and you can go pretty fast. So there's a little more we could add to that, but generally good. Eating sugary snacks gives a short burst of energy followed by a crash. I would say that's another good hypothesis. We might want to again find out what type of sugar, like natural sugar or processed sugar, and then how long does it take to get a crash. Students do homework. That's not really a hypothesis. That's more of a statement, right? We might want to say, when do students do homework? For instance, students do what amount of homework over the weekend versus during the weekday, or how many students study before school or after school. You can look into more of that. I would say students do homework, not so much a hypothesis. It's more of a statement. All right, we'll look forward to seeing you in class.